Okay, today we're going to talk about addition and subtraction of numbers in scientific notation. So let's go to our math interactive notebook and our TOC. We're still in Unit 1, and it's addition and subtraction in scientific notation. And my notes are going to be on page 13. Your notes might be, on a different page if you've taken more than one page of notes on a topic. I have a little bit bigger notebook. So again, addition and subtraction in scientific notation. And got a little crazy over here. Okay, so when you're ready, go to page 13, your notebook. Now, we talked about multiplying and dividing with scientific notation the other day, and we learned that, basically with the coefficients, we either multiplied or divided, and the exponents, changed with regards to the laws of exponents. So for multiplying two numbers in scientific notation, the exponents wound up adding together, and when dividing, they wind up subtracting. When we're talking today about addition and subtraction, I think you're going to see some parallels between what happens in scientific notation, multiplication, division, versus addition, subtraction, like parallel to what happens in fractions. So in fractions, we multiply across, so numerator times numerator, denominator times denominator. And essentially, we wind up doing the same thing with dividing because we wind up doing that flip of the second exponent. So basically, the numerator and the denominator change in a fraction. And we saw that with multiplication and division in scientific notation. Both the factor and the exponents changed completely. When we talk about addition and subtraction of fractions, we're looking for a common denominator. And that common denominator winds up sticking in the answer unless it's simplified. So if you're adding 2/3 and 4/6, you're going to have to find a common denominator. And then if you can't simplify, it would be kept. Well, kind of similar here with scientific notation. We're going to find a common factor or common exponent, for the base 10, and then that's going to stick in our answer. So unlike with multiplication and division, where both the factor and the exponents completely changed, here, that's not necessarily going to be the case, depending on the question. So the rules are going to apply for both addition and subtraction. There's no separate rules for subtraction. So at the top, let's write addition and subtraction of numbers in scientific notation. And like beforehand, we're going to make a chart. So here we're going to have the rule or the step. And the first example problem we're going to do with that is 4.23 times 10 to the 7th plus 3.6 times 10 to the 9th. Okay, so step 1. Is keep larger exponent adjust smaller exponent to match. Okay, so looking at these, we have an exponent of 7 and we have an exponent of 9. So we're going to want to keep the 9. So this is going to be a keep, and this is going to be an adjust. So if I'm going to adjust this up to 9 on the exponent side, that means my factor has to lose 2 place values in order to maintain its equality. So here I'm going to go and figure, that's just adjust. So step 2. So here we just decided which one we're going to keep, which one we're going to adjust. Find the difference between the exponents move decimal left that many times. So again, we're going to move this. We had a 9, so 9 minus 7 is 2. Seems I'm frozen here. I'm still frozen. Give it just a second here. I might have to just close it real quick and reopen my ImageMate. We're having a technology snafu. Shocking, I know. Okay, so 9 and 7, 9 minus 7 was 2. So that means we're going to have to, on the adjust side, we're going to have to move the decimal 2 spots to the left. So when we looked at 4.23, imagine moving 2 spots to the left to get our new exponent. So that means we're going to have 0.0423 times 10 to the 9th, right? Because that's what we're doing. We're changing that exponent, plus 3.6 times 10 to the 9th. So now it's like that we found that common exponent, similar, parallel to finding the common denominator in fractions. We're going to do step 3, which is just add or subtract, right? Depending on what they're telling you to do. The factors, or if you want to call it the coefficients, I like calling it the factors. Some people like calling it the coefficients. So we're going to add and subtract the factors or coefficients and keep the exponent. So in this step up here, when we adjusted this, we didn't actually use the laws of exponents. We actually used the rules for just moving something into scientific notation, that understanding of what happens with place value. So we're not executing the laws of exponents after we add these. So we're going to add 0.0423 and 3.6 together, and we're going to keep the exponent of 10 to the 9th. So our final answer is going to be 3.6423 times 10 to the 9th. Okay. So if you didn't see this, basically I adjusted the exponents here. I just put the coefficients together here because that's what I'm going to add and subtract. I'm going to maintain the common denominator, common exponent that I found. And then I added them together. which gave me 3.6423 times 10 to the 9th. And I can write that in here too if we like looking at that as well. Now, what would happen if our answer, again, is too small or too big? So if needed, right, if needed, like if your answer is not in scientific notation, adjust as we learned in multiplication and division. Okay. So what might that look like? Do another example. This time we'll do subtraction and we'll see what happens if our answer is not in scientific notation. Color for this. Use the green again. So say we had 6.22 times 10 to the 5th. I'm going to make my life easy and subtract 5.5 times 10 to the 5th. So $6.22 minus $5.50, I'm going to have less than $1 left. But either way, one thing to notice here is we can keep both of them. We don't have to find the common exponent because we already have it. They have the same exponent, so we're just going to keep that. So step 2 is irrelevant. 5 minus 5 is 0, so we do not have to adjust anything. If we put these together, 6.22 minus 5.5 and 10 to the 5th was our common exponent. And if we, in fact, we do 6.22 minus 5.5, we're going to come up with 0.72 times 10 to the 5th. And so this is not in scientific notation. In order to accomplish that, I'm going to have to move this over 1 here, which means I would have to subtract an exponent here, right? Making my final answer 7.2 times 10 to the 4th power. Why? Because my factor was too small. Therefore, my exponent decreases. Remember, that's the same rules that we learned with multiplication and division. If it was too large, my exponent would increase. But in this case, it's too small. It's too small because it's less than 1. I don't have a digit in front of the decimal place. So in order to make that happen, I have to move the decimal to get 7.2. And here I have to decrease the exponent. So I go from 5 to 4 because I only had to move my decimal over 1 place. And that is adding and subtracting in scientific notation.